Sorry for that. Oh, I don't know that actually led to something. Okay. Share my screen.
So all these questions, you got it from Google.
Everything. Okay, today we are looking at acid, base, and salts. So we're looking at acid, base, and salts this evening. We are going to, at least you have to bear with me because we must be very, very fast. There's no time again. So let's first start with acid. Who can buy an acid for us? Have you heard of the word acid before? Anyone? Anyone, there's no time. I Google you. Anyone?
Natural.
What can you say about an acid? We have different type of definition for acid. We have close to like
Not
12. Which one do you know? Or which one can you say? Divine anyone.
for my residual knowledge. Acid is a substance which produces high hydrogen ion as its only positive ion when dissolved in water.
Okay, that produces what? Sorry, come again.
Acid is a substance which produces hydrogen ion and using hydroxide as its
That's
only
very
positive ion
that,
when dissolved in water.
that's very good. It ionizes in water to give us positive hydrogen ions, and that is very good. Nice. Okay, we have different scientists that come together to give us the definition of hydrogen. But naturally, like the one that we know traditionally, we all believe that hydrogen is any substance that has a what? A sour taste, and yeah, it is corrosive. We all know that it's regarded to acid as well. So we also believe that anything that is bitter or that gives you a soapy this thing is like a base. That is traditional way of what we believe, that anything that you take and is sour, that means that is an acid. But according to chemically now, like in the chemist way and the normal way, an acid is defined as what? Look at the definition we have here. A substance that produces, like what you said, a substance that produces hydrogen ions, H plus or H plus one, anyone. Because we don't really put one. We already know that once you say any plus without any number, it is plus one. So in water. Now when you try to dissolve, so let me use a layman's term. That dissociate that we use, it means dissolve. That when you dissolve that your substance, it must ionize, means it must give me an ion. So and the ion that it must produce must be positive. Sorry about that. Must be positive ion, and the ion must be hydrogen. Sometimes I can call it a proton. When it is one hydrogen, one element I'm talking about, it is a proton. So it must give me a positive proton or a positive hydrogen ion. So look at the general reaction in water here. So you have HA. So let's assume that HA is our compound. So when I try to put it in water or when I try to dissociate it in water, it dissociates and separates. When it's separated, it gives me H plus and another A negative. So the negative one, I don't need it. But any element or any compound that can dissolve or that can dissociate in water or that can ionize in water to give me that H plus, it is an acid. Then the formula always has a what? Always has the hydrogen in the formula, and it is usually written first. So I can have H2. That was what we're trying to say, that we can have H2SO4. The hydrogen is written first. That's why that sometimes I can tell you that H2SO4 is tetrasulfate 6 acid. And I can also say H2SO4 is hydrogen tetrasulfate acid. Anytime I use the word acid, you will not use the word hydrogen with it, because we believe that anything that can oxidize to give us H plus is an acid already. So I can say H2SO4 is hydrogen tetrasulfate 6, or I can tell you that H2SO4 is tetraozosulfate 6 acid. Let me come again. H2SO4, when you use the word acid, you don't need to include H, like you don't need to include the word hydrogen again. So H2SO4, I can pronounce it as hydrogen tetrasulfate 6. I've got hydrogen tetrasulfate 6. Or I can decide not to pick the hydrogen, and H2SO4, I can call it as tetrasulfate 6 acid. So if they said tetrasulfate 6 acid, you should know that there is H there. Any question? Do you have any question?
Yes, yes,
Please
yes,
stop.
yes.
What's the question? Go ahead.
Like I wasn't in the class earlier when you started, please. The definition of the acid. I really want to get how you said a substance that produces hydrogen ions.
Yes. As the only positive ion. Only positive ion. Yes. When it hydrolyzes the water, or when it dissolves the water, or when it dissociates the water, it must produce hydrogen ion. Positive. It must produce a cation. Do you get that? Hello, do you get that?
Yes, 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 yes. I said I do.
Okay. So you can mute yourself then. When time you have question, please let me know. Okay, so let's continue. And I said we have different scientists again that comes together to give us the definition of hydrogen on their own, apart from the normal one that we know. So we have different scientists that come together. One of them, Inos. Inos gave us his own definition on acid and on base. And that one is one that people always say, acid is substance that rises to water to produce hydrozonium ion. You have heard of that one before. The hydrozonium ion is the H3O plus. H3O plus is when you react a water molecule with one oxygen, you are going to have the H2O plus. So H2O is water plus when you add one more proton of oxygen, you are going to have H3O plus. So that one give us the definition that says acid releases hydrogen ions in water, and bases releases hydrogen. So I don't want to go to base yet. Let me just focus on acid. So by the time we are on base, I read the base part. Give me like 2 seconds, please. Jesus. So I'm here. I'm here.
Ma,
So that is what
ma.
Enos told us. He said a substance that ionizes the water to produce hydrozonium ion. To produce hydrozonium ion is called an acid. That definition of that hydrozonium ion is from Arrhenius' definition of acids. Then another man too came, known as the roasted Lou. That one said an acid is a proton donor. That means they give out themselves. The difference between a proton and electron. Let me write what I want to say. Write it out. This is what we are trying to say. When I say ordinary hydrogen like this is ordinary hydrogen. This hydrogen here, this hydrogen here is a proton. Do you get? Because if you can remember, we said a proton is also means what atomic number. So atomic number is number of proton of an element. So when you talk about an atom that has a charge, it's like a proton. But if I decided to pick only this, if I pick this plus, I don't know why it's not writing. If I pick this plus, my pen is not writing. If I pick this plus, sorry. So if I pick that plus, I don't know why my pen is not writing. That one is the electron. That one is electron. But if I pick that hydrogen, that's proton. So Bronsted told us that an acid are what? An acid are proton donor. That means they give themselves out to another compound. They can join themselves to another compound, to a base, something else. So Bronsted told them that they are what? They are proton donor. They are proton donor. Said something. Lewis said acid is a substance that can accept an electron pair. So in terms of proton, we believe that an acid is what? An acid is a proton donor. But in terms of electron, we believe that according to Lewis, he said an acid that was electron pair. That means they accept electron. They accept electron. They accept electron, but they are proton donor. They can, according to Bronsted, proton donor. According to Lewis, they are what? They are electron acceptor. And the one that is the universal one that we use is the Lewis definition. So by the time you start using Lewis in 100 level. So that one is the most acceptable definition of an acid. And so by the time you reach 100 level, you are going to deal with Lewis definition of an acid. But for JAMB level, you can still use the normal one that said it produces hydrogen as very positive ion. It's still acceptable for that level. But by the time you reach higher level, you make use of the what? Of the Lewis definition of an acid and base, because that is the most accepted definition of an acid, that they are electron acceptor. So moving on. Okay, we are still on Ashnod's theory. Okay, this one says an acid is any substance that releases hydrogen ions. We've discussed that. Hydrogen ions in water. So that is the definition that we all use for the level of SSE. We use that definition. So you can see the H plus has lost one electron. So its charge is what? Is plus. It has lost one electron. So if they use the word it has lost one electron, don't forget that we are trying to reverse back to what? Lewis definition of an acid that said they are what? The electron acceptor. So it's going to then look at your chlorine. It gained one electron, and so its charge is what? Negative. This one you are used to that sign. That one is right from SS1. That anything that has plus means it can give out. While anything that has minus means it can receive electron. So we are still on arenous acid. Look at it, it's produced. So we're going to waste time on that again. So look at some question. I do not ask us to see which of among this one that we have, which of these can we know if truly is an acid according to Arrhenius? Because Arrhenius told us that they must produce what? Hydrogen in that reaction. So the first one I have the NH3. NH3 is what? What's the name of NH3? Any person? Anyone?
You're asking a question.
Yes, I said what is NH3? NH3 is what is the name? Ammonia. Thank you. God bless you. So our NH3 is a radical that has plus, and your NH3 cannot ionize the water. It is not an acid. It is a base, so it cannot give me hydrogen. So that means my NH3 is not there. But look at the AClO4. Don't forget again, when we are trying to talk about when I explained the hydrogen, said when we explained the acid, we said the hydrogen is going to start that compound. if truly that compound or that substance is an acid.
That's
Let me take
nothing.
it. Let me take it again. If truly the substance is an acid, we said it must start with what? Hydrogen. So from that definition sef, I should know that my ammonia can never be acid, can never be an acid, because it's not starting with what? Hydrogen. It starts with nitrogen. So my nitrogen is bonded to my hydrogen. So which shows that it is a base. But if I check the remaining ones, if I check option B, HClO4, it starts with what? Hydrogen, which shows that that kind of a substance is an acid. So if I try to oxidize it, I will get plus. So who can try to dissociate it and tell me the formula? Dissociate HClO4. How will you get it? Hmm? Anybody? This
Yes.
one is marked HClO4. Yes. H plus plus what? Hello, is anyone talking? Anybody? Is anyone talking?
No, no,
Please, you
no.
know that. Okay. Dissociate HClO4. I've helped you. You are going to get H plus. The what will be the second one? If I dissociate it. Dissociate is like you are trying to scatter it. That means if I drop HClO4 inside water, that is the definition of acid. That when it is analyzed in water, that means if I drop that substance in water, it will dissociate. It will scatter. So when it scatters, it's going to give me hydrogen as a positive ion. As simple as that. Nothing more, nothing less. That is what you are saying. Find the definition of acid. That when you dissociate any substance in the water, it produces hydrogen as the only positive ion. Means if I put it, just like when you always put your vitamin C, if you drop your vitamin C inside water, you see the effervescence now, you see what will happen. And some of you love that, you love the sound. So because of that, you always dissolve your vitamin C just to hear that sound because you love it. So once you drop the vitamin C inside the water, the sound is telling you that everything that holds this thing together is trying to and to give you solution. So if I put my HClO4 in water, it's going to dissociate. So dissociate into what? That is the question I'm asking.
H plus ClO2 minus.
God bless you. ClO4 minus is not, it's going to be ClO4 minus. If it is 2 minus, that means my hydrogen here is going to be H2 ClO4. That should be the compound.
Okay.
Because don't forget that when you are forming a compound, they interchange charge. My hydrogen is always plus 1. So I have ClO4 minus 1. But if it is ClO4 2 minus, you know that H is plus 1. That means that one, it will give it to ClO4. And the ClO4 will give it 2 to H. So I'm going to have H2 ClO4. But the compound is not H2 ClO4, which shows that ClO4 is minus 1. So thank you. So if I look at this dissociation, you can see that I can get hydrogen plus from this dissociation. And again, looking at that compound, it starts with an hydrogen, which shows that this thing is an acid. So, and it also fits into what? Arrhenius equation that says when I dissociate it in water, I will see, or it's going to produce an hydrogen, a proton, or an hydrogen as a positive ion. So it means HClO4 is an acid. Okay, let's pick the second one. Let's pick the C. The C is KOH. Even looking at it, it does not start with what? Hydrogen. So since it does not start with hydrogen, it means KOH is not what? Though it has an hydrogen, but as long as it's not starting with nitrogen, that substance is not an acid. So moving on to the next page, HBr. It starts with hydrogen. So it means I can say, okay, let me guess. Oh, since this thing starts with hydrogen, it's likely to be an acid. It's likely to be an acid. So what I will do is just for me to do what? It's just for me to dissociate it in water or dissociate it and see if truly I'm going to get hydrogen as a positive ion. So if I dissociate it, I'm going to have HBr. and HBr is going to give me H plus what? Br minus. So as long as I'm getting H plus, it means HBr is also an acid, which fits into the definition of what? Arrhenius definition. So the last one you can do it. Oh, I love this one now. It's like the example, like it's like the example I explained. This one is H2SO4. So you can dissociate H2SO4. H2SO4. Dissociate it, please. Who can dissociate H2SO4? Anyone? Hello, please. That in class. I can't be the only one talking so that we learn together. So let's dissociate H2SO4. Say anything, even if it is rubbish. That's why you are here. If you know it, you will not be in class. You will not be here. So it's because you don't know it. That's why you are here. So if it is rubbish, say something, please. At least we know where to put in more energy. But if you guys are not talking, there's no how we can know where to help you.
Sorry, please, what's the question?
Just try. Don't say anything. Even if it is rubbish, say anything. Yes, you can dissociate H2SO4. Scholars now,
Please,
scholars in the house.
there's something I want to tell you. I want to beg from you. You
Okay.
should please be breaking down your words. You should be breaking down your words. So from there we can at least pick up and the class become interactive. You should be breaking down your words.
Sorry,
Guys,
what
let's
is it that am I too fast or I should be using layman's term or what? Is it the English and is it the words?
maybe all of them. All of them you are fast and
Yes,
because the class is not it's not interactive. There's nobody talking. So maybe that's the reason or I don't know.
Okay. Okay, let me go back. Let's assume that because okay, no problem. Let me assume that we don't know it like as if because it's just like a revision class. Okay, let me go back.
please, can you tell me the question again? I was not around.
No, no problem, no problem. Let me break it down. But in that breaking down of words, I can't really use because there are some terms that I use in chemistry. So that's how I can use normal English for it. But I'll try and use
Yes,
normal English.
yes, understand you.
Okay, no problem. Okay, so what I'm trying to explain here, you said everybody we are all familiar with normal definition of an acid. And that acid says that is the one that everybody is familiar with. It says when any substance ionizes in water or dissociates in water, it's going to produce hydrogen as the only positive ion. That is the normal definition that everybody is very, very familiar with. And it is acceptable. We now said after that, there are some scientists again that comes together to give us more definition on an acid. That an acid is not only based to that definition. Oh, it's not that it is not acceptable, but our acid is far more than that definition. So out of these scientists that come together, the first person is Arrhenius. And Arrhenius gave us his own definition on an acid. And what he said is, anytime you dissociate your substance in water, it's going to produce hydrogen or hydrozonium. That man actually used the word hydrozonium. And you know the hydrozonium to be H3O. Hydrozonium is H3O plus. This is the meaning of what he said. That when you dissociate a substance, it's going to produce hydrozonium ion or it will produce hydrogen ion as the positive ion. That is its own definition. Another person came too, known as Bronsted. And Bronsted said, our proton donor. That means they donate proton. That is what that one said. But let me take it one after the other. Let us combine together. So let's still focus on Arino's definition. And I think that one is clear now. That one said when you dissociate substance
Why
in
you
the water,
taking it for me
zonium or hydrogen ion, which is very fine. Now the question here now says from his definition, and I also
Don't worry,
explained.
I'm bringing that word tomorrow. I'm bringing that.
So there is also another definition that is there, and that one is sorry about that. I'm a bit lost. Okay, where am I? Okay, trying to explain Arinos, Abi. Okay, I said something again that for you to recognize your hydrogen, your acid, it must start with hydrogen. That's what I was trying to say. An acid will start with hydrogen. And I use an example then that if I want to pronounce H2SO4, which is an acid, if I want to say H2SO4, then I can pronounce this thing with this. I can call this hydrogen tetraodosulfate 6. Hydrogen, I can use by calling the hydrogen first. So I will say hydrogen tetraodosulfate, and I will not put the word acid again. So it is wrong to say hydrogen tetraodosulfate 6 acid. That's what I'm trying to correct. That statement is wrong. Statement of hydrogen tetraodosulfate 6 acid is wrong because hydrogen is an acid already. If an hydrogen starts with substance, it's telling me that it is an acid. That is the meaning. So I can say just that word hydrogen will not include the word acid. So I'll just say hydrogen tetraodosulfate 6 acid. Hydrogen tetraodosulfate 6. Now, if I want to include the word acid, I will not measure the word hydrogen. I will just say tetraodosulfate 6 acid. So I don't need to measure hydrogen again. I'll not measure it because I use the word acid. So I'll just say tetraodosulfate 6 acid. But if I want to include the word hydrogen, I say hydrogen tetraodosulfate 6. That includes the hydrogen. Then moving on. So I want to start breaking it down. So moving on, let's say our compound as an acid, we always start with hydrogen to know that, oh, this substance is an acid. So a substance that you see that does not start with hydrogen is not an acid. So from this little information, we now want to gather it together to answer this question. And the question says, recognizing arenous acids. Which of the following are considered arenous acid? First one, they gave me option A, NH3. So they are trying to ask me that is NH3 an acid? If yes, is it also an arenous acid? And for me to know if it is arenous acid, it must go with what? With the definition of arenous. I said if I dissociate any substance in water, I must get hydrogen positive or hydrogen positive. So look at NH3. NH3 does not start with hydrogen. It's not an acid. So I move to option B. Option B is ClO4. HClO4. So if I look at this substance, because it starts with H, then this one is already giving me, or it has already told that, oh, this is an acid. So I now want to see if I dissociate this thing, am I going to get hydrogen positive ion? So that was the English I was using, that dissociate. Dissociate means break it down. And I use an example that some of you love the sound of vitamin C when you dissolve it in water. You love that sound, that effervescent sound, you love it. And I say it's the same way that when I drop HClO4, if I drop this substance, if I drop it in water, it will dissociate, means it will scatter. So in the process of the scattering, I'm going to get hydrogen positive. So I told you that dissociate this thing, which means scatter this thing for me. That's what I'm saying. So if I want to dissociate it, I'm going to have H plus, then CnO4 minus. Are we still together?
Yes, ma'am.
So, but when someone decided to break this down, the person now said ClO2 minus, and I said it's wrong. That's what I was trying. That was what I decided to. That was what I tried to correct. So when the person helped us to dissociate, the person said H plus ClO4 2 minus, and I explained the reason this cannot be minus. That if you look at the HCl, you know that we have HClO4. There is nothing like I do not have H2 for me. HClO4. So it's not H2 ClO4. If it is H2 ClO4, I would have known that this here is coming from ClO4. But there is no 2 here. So it means it is ClO4 minus. It is one that is there. Because if you know your chemical combination, you know what I'm saying. So let us digress. It's time to treat that one, then you understand better. So that is the way to dissociate it. So it means when I dissociate AClO4 and I'm getting H plus, it shows that it is what? An acid. Option C is KOH. Is it an acid? Is option C an acid? And give your reason why it's not an acid.
No, it's not an
No,
acid
it's not
because
an acid.
you said an acid usually
Yes,
starts with a nitrogen.
exactly. Option. So KOH is not an acid. Very good. Then let's go to the D, HBr. HBr is going to be what? Definitely an acid. So I can also dissociate ABr. So if you want to dissociate it now, who can give us? Who can help us with that? Help us to dissociate ABr. So what about aqueous acid? Anytime you hear the word aqueous, it means there is water there. They dissociate it in water. So to have an aqueous acid, if I dissociate it in water, I'm going to have what?
Don't break it.
Yeah.
We're going to have H plus
H plus. Thank you.
Don't pick it
BR,
for me again.
BR minus.
R minus. That's beautiful. That's beautiful. So you can see that I still produce H plus. So definitely HBr is an acid. That's awesome. Then the last one is H2SO4. H2SO4. This is the sulfur 6 acid. H2SO4. If I want to dissociate it, who can help us?
H2
H2SO4.
plus.
H2 plus like this.
No,
Is it like this?
the no the H, then the 2 is a subscript, then the plus is on top.
Okay. Like this.
Yes,
Okay.
plus
Plus
SO4 2 minus.
SO4 2 minus. I'll mark this right, but I'll mark this wrong. So can I pause out? This is right, but this one is H2 plus is wrong. So can I help us?
Is the 2 supposed to be in front of the H?
Thank you. H plus. Because an hydrogen ion is always H plus. But if I say H2, it's no more an ion. This is a gas. This is a molecule. So anytime I say H2, I must not put any charge on it again. I must not put any charge. Once I say H2, it's no more a charge. But if I want to make hydrogen a charge, it is always H plus. So any number that I want to add should be at the back, to act as the coefficient, the back, because it's always H plus. So I hope that one is clear. So let's move. So we are still on arenous acid. It said arenous acid increases the concentration of hydrogen ions in an aqueous solution. And I told you that because anytime everybody, you are familiar with AQ in that bracket, but some people do not know the meaning. Anytime you see AQ, it means that solution, that substance is an aqueous, means it is in solution. There is water in it. Sometimes you can see something like this. Na and they'll put SA. This one is still in solid. And you can see something like this, NaCl, and they'll put AQ there. Means they react this thing takes place in water. So NaCl means there is water inside that NaCl. And I can also have ordinary NaCl and put S there, trying to tell you that it's not in aqueous, it's not in water, it's still in what? Solid form. You have to be careful of your state of your compound. So in an aqueous solution, so this our HA here is trying to tell us that this is a compound of HA, and when they try to dissociate it, the taters give us what? Hydrogen ion, you can see H plus and another negative. So it's going to produce cation and anion. What do we mean by cation? Cation are positive substance or elements, while your anion are the negative elements. So cation, this is what I'm trying to say. It's not cation, it's called cation. And we have the word anion. Anion as negative, while the cation are the word positive. And cation are what? The electron donor. They can give out. While anion are what? Electron acceptor. They want to accept. So that one is clear. So this one is just trying to bring more explanation on Arrhenius theory. So we can move. That's one of the words. You see the same thing that when you have acid and base reacting together, this one is a Bronsted law. So let's go to, okay, we are now in this acid. So let's go to the second scientist. So another scientist that comes out to give us definition is a Bronsted Lurie definition. And what is Lurie said? He said any acid is any species that can donate a proton. So according to Bronsted, he said acid is a proton donor. That is what he said from Bronsted. We've looked at this guy, Arrhenius. Now we're looking at another person. So this person also give us the definition on an acid, and he said acid is any species that can donate a proton. So because they call them proton donor, they can donate a proton, and we call them a proton donor. So for example here, I can have an equation like this. I can have this equation ACl, sorry, let me try to reduce my hand. ACl plus NH3 plus NH3 to give me NH4 plus NH4 plus then plus Cl minus. So if you look at this equation, let me change this color. I think this color is not really clear. Let me use red. ACl HCl plus NH3 to give me NH4 plus then plus ACl minus. ACl is what? Hydrochloric acid. You can see that is an acid. Yes. The NH3 is a base. That is ammonia. So at the end of the day, I'm having NH4 plus plus Cl minus. That's what I'm having as the dots. I'm having I thought this one would give me nice color. It's even out of it. Yeah. I'm having NH4 plus and I also have Cl minus. So if you look at this NH4 plus, you should know that it is coming from NH3. but something happens to this NH4 plus, which is ammonia. It means that another element has been added to it. What element? NH3 turns to NH4. So what?
Ammonium.
Yes. So what element is added to it?
Hydrogen.
God bless you. So an hydrogen is added to it, and that hydrogen that is added to it is coming from that
Ma?
hydrogen is coming. The hydrogen that is added to the NH4 is coming from where? Who gave the NH3 that one hydrogen?
Mm,
HCl.
the HCl.
You. God bless you. It's coming from AC.
Yes.
HCl is an acid. So it starts with what? Hydrogen. If I dissociate my ACl, I'm going to have H plus or Cl minus. So because of H plus, H himself decided to give himself out to NH3. That is to show a boosted definition, the addition of proton. They are donor. And I explained that time that when you hear the word proton, it's like what I'm talking about an element himself. It's different from electron. Electron is trying to say, okay, if I have two
Spider
let me
oxygen.
give you the two electrons, but I'll not give you myself. But anytime you hear proton donor means they are giving themselves out in that equation.
Okay.
So hydrogen is attaching himself to NH3. So he went to NH3 to go and add himself to NH3 to become NH4. So that is the definition of a Bronsted that I said they are what? Proton donor. They can decided to give themselves out. They can decide to go and join people so that the work will be faster. So any acid that can do that, if any substance, rather any substance that can do that is also called an acid according to Bronsted. That is what that says. HCl will donate its protons to ammonium to form ammonium ion. Form ammonium when dissociates with water. That is the definition of this person. Then the next person we have okay, we look at this. So that is both much on that one. So the next person we have, okay, this one is you can see this one is the roasted definition. Look at HA as an acid. Does dissociate. By the time they dissociate, the HA will dissociate. So the H is going to be plus, while the A is going to be minus. So the A will not decided to do what? To donate himself. Because according to Bronsted, he said an acid that what? Proton donor. So hydrogen, that H will to gift himself to B. So he will go and meet B, join himself to B. So it's going to be A minus B. And these people, please don't mute yourself. I'm sorry, please mute yourself. Please mute yourself. Thank you. So for the product, we are going to have conjugate base and we are going to have conjugate acid. So the acid that will be formed, because there is still what there is still is a cation, it's still giving us positive. So the acid that will be formed is going to be a conjugate acid. Then we move on to Lewis definition. Then this is the third man, Lewis acid. This is the third man that gave us definition. So Lewis said an acid is an electron pair acceptor. Lewis focus on electron while Bronsted focus on proton. Please, it's not the same so that you not mix it up. Bronsted focus on what? Proton, while Lewis focus on electron. And Lewis said all acid they are electron pair acceptor. They accept electron. And I said the Lewis definition of an acid is the most accepted definition for acid. That by the time you start from 100 level, you are going to start from Lewis definition. And that's the definition you are going to use. And you use it mostly. Even in your organic, there is organic part that you will use your Lewis acid very well. For the craft this you use your Lewis acid. So starting from 100 level above, the most accepted definition of an acid is coming from the Lewis definition that says that an acid is what? They are electron acceptor. But I said for our level for JAMB, they can still collect the definition of arenos, which is the common one that when they analyze in water, they give hydrogen as only positive ion. they can still collect that one for our level. But please, you have to know this before you enter the next level, that the most accepted definition of an acid is coming from Lewis, that said all acid or acid are what? They are electron pair acceptors. They accept electron. And I've told you that Lewis focus on electron while Bronsted focus on what? That one focus on proton. Okay, so let's look at Lewis acid here. Don't focus on bases yet. So let's focus on an acid. So look at what they just try to give us. This one say, yeah, I love electrons. So anybody that is electron acceptors, they want to, this one is just normal English, when they want to collect electrons. So that I love electron, come and give me electron, I'll collect electron. That is how Lewis define all acid for us. So he said typical example that was cations or positive ions. Despite that these people are positive, they are still electron acceptor. And in normal chemistry, we know that any element that is positive gives out, they are donor. That is what we know them, that they give out the electron because they are positive. But Lewis is telling us that if that substance is truly an acid, that's why that is going to have plus, or that's why it's going to be a cation, it's still going to accept electron because they love electron. It's just that when somebody is very selfish, that you have abundance and you still want to collect, that is how they behave. According to Lewis, that they have abundance, though that's why these people having abundance electron, they still want to collect, so they call them electron acceptor. They love electron, they love collecting electrons even if they have more than enough. Then the next one is, they say there are species without a complete valence shell. The valence shell is not always complete. So normally we know that for a valence shell to be completed, the first shell must always take a maximum of 2 electrons. The second one must take a maximum of 8 electrons. The third one must take maximum of 8 electrons. And the next one before you have 18. This method is only applied for the first 20 elements. 2, 8, 8, 18. We use that structure for the first 20 elements. Then moving from the 21, you will use 2, 8, 18, 18, 32. So this shell, if I look at this valence here, this one is a complete shell because the first shell has the maximum number of electrons that it's supposed to have, which is 2. It is complete. The second shell too, it is complete, which is 8. The third one is complete, which is 8. But Lewis is telling us that if truly this substance we are talking about is an acid, they will always have incomplete valency shell. So it means it's likely for them to have 2,7. That means this one can be complete and second one can be incomplete, because for this second shell to be balanced, it must always be 8 electrons. So an acid, according to Lewis, can also have incomplete valency electron. That's what he's trying to tell us here. Then the third one, he said electron deficient, that is conjugate systems. And you know the meaning of electron deficient, that means they are not always certified. How do I say? They are not always okay with electron. They always want. So they every day of their life they are like they look like they are lacking. Let me put it that way. They look like they are lacking electron. Even if they have, they still give you that face that I still need the electron. So they are always deficient. They are always electron deficient system. So that is the definition for Lewis. I don't know, maybe we are screenshotting it all because I'm trying to move on. So let's still look at it. It still says a substance that can accept, you can see, a pair of electrons to form a covalent bond. They will still accept pair of electrons to form a covalent bond. That is an example of an acid according to Lewis. This thing. So in that order that I said, not all acid and base reactions involves proton transfer. That is why that we said the Lewis definition of an acid is the most acceptable, because it tries to rule out Bronsted definition that says acid are proton donor. So it's trying to tell us that not all acid and base reaction will involve proton donor. We involve the whole element to go and join another person. There are some that the element will still be there, but something will still happen that element will still collect electron, and we still be looking at the person that is collecting electron from without joining that person. So that is what Lewis is trying to tell us, that chemical substances that can accept a pair of electrons to form a covalent bond and all. So let me see before I now go to the strength of an acid. Okay, let's look at another. Okay, there is a very popular example of Lewis acid, and that is AlCl4-. Please, it's very, very popular. It's very, very popular. Lewis acid do not have hydrogen atoms in the molecules. They don't have it. They don't have hydrogen atoms in the molecule, but they have empty valence orbitals. Now, this is what we are trying to say. Look at Al. Oh, what's this? Okay, let me use this body. So we have AlCl3 plus Cl minus to give us AlCl4 minus. This AlCl4 minus is a Lewis acid. Is a Lewis acid. Just like I told you, they don't need. By the time we explain, you understand. They are rich. They don't need though. But there's these people that they just love electron. They just want people to shall come. Even if they are okay with what they have, they are not always okay. Even if they have abundance, they are not always okay. So, and it happens when there is what? When there is empty valence orbitals. An empty valence orbital, then another this can just say, oh, let me just go and join to these people. And we said something. I said Lewis acid do not have what? Hydrogen atoms in their molecules, but they are acid, but they will not have hydrogen atom in their molecules. So look at this. What happened in this situation is like this. Normally we believe that what is the atomic number of aluminum? It is what? 3. So it's going to have 3 valency electron. So if I have aluminum like this and it has 3 valency electron, which is 1 year, 1 year, and 1 year, it is complete now because it only has what? 3 valence electron. So out of these 3, one hydrogen is coming, one chlorine is coming to join with it so that they can form a bond like this. Another chlorine is coming again to join with it. Another chlorine again comes to join with it. You see, this my aluminum has used all its what? It has used all its electron that it has. No more electron. But if you look at it, it has not formed a complete octet structure because it must be 8 electrons. But if I count for aluminum, it's still 6. This is 1, 2, 3, 4, 5, 6. So it's having what? An empty valence. Though it still needs 2 people. It still needs someone to come and join it. But it does not have electron to make that combination to happen, to make that reaction to happen. It's just like when you want to get a phone and you just go and meet your uncle, you meet someone to give you a phone and to buy a phone for you. Even your uncle will ask, how much do you have? So but this aluminum does not have anything like that. It does not have any contribution, but it needs to be balanced. So because of that, another chlorine will now come and join. That will bring its 2 electrons to come and join this my ACl. That is how a Lewis acid is being formed. There is always an empty valency electron, and so because of that empty valency shell, it makes it to be what? It makes it to have incomplete shell. I don't know, maybe you got that explanation, please. Are we still together?
Yes, yes, yes.
This one.
Okay, thank you. That's very good. So that is the empty one we are trying to say. Aluminum has used the 3 electron. It is 13, and the valence electron is 3. It has used the whole 3 to combine again with another chlorine to form, but it's not yet complete. Aluminum is not complete yet. It must be 8. So because of that, and aluminum has used all its electron, even though it has abundance, plus 3 is enough for someone to be rich, but it has used all its 3. So there is a vacancy, there is a vacant this thing on its head, but it needs to be completed. Because of that, another chlorine will now come and say, oh, let me help you. So when another chlorine now come, that is when you now have AlCl4 minus to form a Lewis acid. So anytime you see a Lewis acid, you should know that, oh, this compound has vacant shell and it is incomplete shell. So in this reaction that I'm looking at now, the empty valence orbital on that aluminum atom in the AlCl3 that I explained, we accept a pair of what? Electron from the Cl to form the ACl4 minus. So that is Lewis. For this level, actually, I don't think we, but please, if you know it now, it's just like a bonus, just like a bonus to us. So I'm not sure, maybe it's part of the past question, because we are going to have question. The question is going to be past question standard. I don't know, maybe it's every week or every month. but you are going to have a standard question, and it's going to be done online, please. And it starts the time, so you have to be you have to be fast, because it will close down and submit by itself. So if I'm going to set the question, it's likely, but it's like I'm going to use JAMB standard. If Lewis acid and this bracelet is not there, I will not set it, but if I see it there, just expect it. And if it's not there, at least I'll still set like 1 or 2 on it. So please read and understand it better. So the next one, we are moving to strength of an acid. So when they ask some people types of an acid, the first thing, I was surprised when I asked someone, and what I heard was strong acid. The person said, I said types of an acid, and the person had said strong acid and weak acid. That is not, if it is right, please, it is 0. Types of an acid is organic and inorganic acid, not strong acid and weak acid. Strong acid and weak acid are known as the strength of an acid. While types of an acid is inorganic acid and organic acid. And we all know that the inorganic acid are the one that we also call mineral acid. They are man-made, or they are formed from a synthesized mineral salts. That's where we get them from. While the organic are the natural ones. So it might be the acid you get from maybe the soy milk that you take, or it can come from most of your fruits, your grape, your orange. It can come from milk. You can get your acid from. So all these ones are natural acid. That's why we call them organic. While the inorganic are the artificial, or the man-made, or the one that are being synthesized from mineral salts. So that is types of an acid. If it is WAEC, maybe I don't know if we have WAEC students here, but please, that is the type of acid we have. But here we are looking at strength of an acid. So we want to talk about the power. That is meaning of the power of an acid. So we have the two types. We have the strong acid and we have the weak acid. So for the strong acid, these are acids that what? They ionize completely in water. They dissociate completely in water. When they dissociate, they form cations and anion completely, not partial, total dissociation. So you can see they say a complete dissociation. But when you talk about your, okay, let me just explain the strong acid before I now start comparing it. So an example of strong acid, we have the H2SO4. Let me list it. So that we have the H2SO4 is a strong acid. ACl is a strong acid. HNO3 is a strong acid. These are strong acids. Please, we have weak acid that is close to this HNO, and that is HNO2. That is weak acid. But HNO3 is a strong acid. Then your H2CO3 is a weak acid. So these are the 3 most common strong acids that we have: H2SO4, ACl, and HNO3. When these 3 acids ionizes in water, they ionizes completely in water to give me positive hydrogen proton, and they'll give me anion, which is the remaining negative part of it. So we can dissociate this, so I don't want to waste much time on that. So moving on to the weak acid, we said weak acid are organic acid. They are only slightly ionizes in water. For strong acid, their ionization is 100%, while for weak acid, it's just like 0.4. You can see it's still far. It's not even up to 1%. So if they want to ionize in water, it is 0.4, and most of them are organic acids. So example of our inorganic, example of our weak acid, we have the H3COO, which is what? Ethanoic acid. We have the HNO2. We have H2CO3. Anytime your hydrogen reacts with your carbonate oxide, it's going to give you a weak acid. So your HNO2, H2CO3, H3COOH, they are weak acid. That is the strength of an acid. So if they dissociate this thing in water, they will not dissociate completely in water. So let's look at the difference. Let's look at the difference between the two. For strong acid, it gives us what? A complete dissociation. While weak acid gives us what? Partial dissociation. Another thing under our strong acid, all the molecules, dissociates to become ions in water, but few molecules dissociate to become ions in you did not see it, to become ions in water. Then for the strong acid, we have example say nitric acid. Your nitric acid is HNO3, that one called nitric acid. Your hydrochloric acid is HCl, while your sulfuric acid is H2SO4. Your ethanoic acid is the H3COOH, while your citric acid is the acid that you get from your what? From your orange, so on and so forth. Then we have some properties of acid now. That means we are moving on to the physical properties of an acid. Number one, it produces H plus as H3O plus, any one of it, ions in water. That means when they dissociate in water, they produce that. Then the taste is what? Is sour. It has a sour taste. The taste is sour. So if you take unripe fruits, that's when you feel the acid. Unripe, you feel it most when you take unripe food, or you take lime. It is very very sour. Then the next one is it reacts with metals to produce hydrogen gas. They react with metals to produce hydrogen gas. So it can react with sodium, it can react with copper, it can react with any of our maybe transition metals or our group 1, group 2 and group 3 metals. The next one is it can conduct electricity. Acid can conduct. If you are very familiar with all these short videos, there was one that I watched that they will put wire inside the lime and you see the light to come up. You now be like, where is light coming from? Since it's an acid, and we know that when they ionize the water, they will form what? They will form ions. And for anything that can produce electricity, there must be an ions. And if the ions is now in water, that means there can be a mobile ions. So anytime there is a mobile ions, anything that can give you mobile ions can conduct electricity. Anything that can produce ions. So that is why your NaCl2, if it's in aqueous solution, your salt can conduct electricity. Because if I dissociate my NaCl, I'm going to have NH plus and Cl minus, which is a total of what? Ions. So that one too can do what? It can conduct electricity. So electricity is not something you should be awful about. It's just something that from what we have learned, you should be able to know that, oh, this is why the light is coming on. So anything that can dissociate to give us cations and anions completely, not partially, completely, it can conduct electricity. The next one is what? This one is common. It turns blue litmus paper to red. And this one you are going to use it when you are doing your titration, your salt analysis. Okay, I think we've above that level. So our salt analysis, we make use of our litmus paper to know the type of gas that is coming out. Is this acidic gas or a basic gas? So for us to know that it's acidic, it has to turn what? Litmus papers to red. Then the pH is less than 7. The pH is less than 7. So when you have your pH this way, you have your 7 at the middle. So we have our 6 up to 0 here. Then from 8 up to 14. So from 8 up to 14. Let me see. I think I have a pH. Hold on. So that you see what I'm trying. Okay, I have a pH. So look at this pH. This is a scale here. You can see that the middle one here is 7. Then from 7 we have our 6, our 5, 4, 3, 2, 1 and 0. Then here we have our 8 to 14. Now your 7 here is showing you that it is neutral. So example of anything that can give you 7.0 when you use your litmus paper that is neutral is water. So the pH of the water is 7. So when I test the water and I'm having like 5.4, that water is not healthy for me to drink. That means that water is acidic. And if I even test the water again, I'm seeing like 8.4. It means that water is basic. It's not healthy for me. A normal water, a pure water should be 7, should be neutral. So from 6 to 0 here is called acidic. You can see that they show the area is acidic. But there is strong acid and base and weak acid. Your strong acid should start from 0, 1, 2 to 3. That is your strong acid. So by the time I started having like 3.5, 3.4, 4.0, 5 point something, it is a weak acid. Not the higher the number. Some people always make that mistake. They'll tell you, since it is 1 to 3 is increasing, that the higher the number, the higher the acid. No. The lower the number, the lower the what? The lower the number, the higher the acidic of that substance. So when I measure the acidic of a particular substance and it's giving me like 1.5, that substance is very very acidic. It's a strong acid. But if I measure the pH of a particular substance and I'm having like 4.6, it is a weak acid. That's why that the ELISA you are using, better ELISA must give you something like 5.5. or must give you something like 6 point something, it must be a weak acid, because the pH of your head, the pH of our head is 5 point, I think it's 5.5. So any product I want to use should be in that range of either 5.5 or something higher than what 5.5, to be a bit lower than my hair. That is why it's not advisable for people that tint their hair. You put chemical, I always look at them, I'll just shake my head, they don't know the meaning of what they are doing. Your chemical is very, very acidic. So when you are putting, my scalp is 5.5 and I'm using a chemical, two different chemicals, giving me something like, the pH is giving me like 4.2, and I use it on my head. I said I'm doing guy, I'm joking with cancer if I'm not careful. And now you look at some people again, they will tint their hair different color within 1 month. There are pores. We have, you know, that you have holes. So as you are putting the chemical, it's entering your brain. So if the person is not careful, the person will develop brain tumor, because you are adding more acidic substance into your head. So you don't pity your health. So this pH, the bathing soap too, we use our pH for it. That is why that you have to regulate. People that produce, you can't just go to one nearby shop and start looking for skincare that is not lost. You are on your own. If they spoil your body, you are on your own. If you start having skin cancer, you are on your own, because I don't know what does not lost that you're looking for. So everything must have a pH. So if you don't buy something from a professional person, you might use something different for yourself. So all these chemicals that you are applying on your body, be careful on the way you use them. ELISA should be done 3 weeks in a year, not every time, not every month. You'll be putting chemicals in your head. You just start developing it because necessary. Because all these things, some of them, they don't even measure the acidic. Some are too high for your health. So moving on to that is just an advice. So that's why a chemist student, there are some things that you should know as a chemist. So moving on to your basic, that one is, the higher you go, the higher it is what? It is basic. So it's like opposite of acid. If I measure 0.2 for a particular substance, and I also measure like 12.5 for a particular substance, that 12.5 is very, very acidic, more than 8.0. It's not like an acid. I hope the explanation is clear, please. Are we okay with the explanation?
Yes,
Are we
ma'am.
still okay? So for basic is the opposite of what? Acidic. The higher the number for a basic, the higher the basicity of that substance. But for acid, the lower the number, the higher the acidic of that substance. So that is the pH. So I think, okay, we are trying to differentiate these two, right? Okay. No, I think it's not here. Okay, it's this one. So we said, is it here? Okay, we are trying. Okay, so the pH is less than 7. So from 6 to 0 means it is what? Acid. It is acidic. Then they also react with what? They react with bases to form salt from water. And when an acid reacts with base to form salt and water, that reaction is called neutralization. That is when you have your salt and water. So your acid can also react with your base to form salt and water. And they are also strong electrolytes. That is what we say, they can conduct electricity. Then let's look at the chemical properties of an acid. So an acid is sometimes, we all know that one. So the first we said bases to form salt and water. That is the chemical reaction of that acid. When you react to acid with your base, they form what? They form salt and water. The another one is what? Metals to form salt and hydrogen gas. They can also react with metals and they will form salts and they will also form what? Hydrogen gas. Then they can also react with carbonate. Your carbonate is what? CO3 to form salts, water and carbon dioxide gas. So anytime you have a reaction between CO3, 3 things is being formed. We are going to get CO2 and we are going to get H2O from that reaction, please. So put it at the back of your mind. This is what I'm trying to say. Let's say I have something like this. If I have CaCO3, this is a metal, right? Ca is a metal, CO3 is a carbonate. So it's going to give me, because of there is carbonate in this reaction, so my product is going to form salt, which is CaCl2. It's going to form water, H2O, and it's going to form CO2. Please. So anytime you see CO3, 2 things will come out from it. H2O will come out and CO3 will come out from CO3. CO3. CO2 will be formed, H2O will be formed. But that CO3 I can react with any acid. I can react with ACl. Or I can react with H2SO4. So once I react with it, it's going to form water and CO2. So that's what we are trying to say. So anytime they react with carbonate, they are going to form salt, they will form water, and they will form dioxide gas. So when I have CaCO3 and I react with any of the acid, which is ACl or H2SO4, I'm going to get that product. So any question on an acid? Any question?
Keep going.
Okay. And there is one more thing I want to add on that acid. That one is the can ask us a solution that why is it that when you add your ACl to your methylbenzene, it does not give a reaction on litmus paper? Our methylbenzene is also known as toluene, and this is what we mean by methylbenzene. Let us go into organic chemistry a bit. So when I attach CH3 to it, it is called methyl benzene. CH3 is called methyl, right? So when you attach it on your aromatic ring, your benzene ring, it is called methyl benzene. And methyl benzene is known as toluene. This one is blurry. So it is called toluene. So when I add my acid to this reaction, if I put my litmus paper on that solution, I'm not going to see any reaction. It is not acidic. It will look like a neutral. And the reason is because in that reaction, there is no production of H3O plus. It does not dissociate to give me H3O plus. So what actually brings the color change is the presence of H3O4 that is being formed, or the presence of what hydrogen positive that is being formed. That is why it is called an acid. So any solution that does not give you, that does not dissociate to give you H plus or H3O plus will never give you a solution of what acidic solution. So I just saw the question somewhere, so I decided to add it. So let's move on to base. So what do we mean by base? We said a base is a substance that produces hydroxide ions in water and it has a bitter taste. This one is the normal and the popular definition that we all know for base. That when they dissociate that one to in water, it's going to produce hydroxide, and hydroxide is OH minus. OH minus. This is hydroxide. OH minus. So according to our definition, it says a base is a chemical substance that has a pH higher than 7. Then on a scale from 0 to 14, lower pH solutions are strong acid. We've explained that one. The higher pH solutions are bases. So solution mentioned this are neutral. So a base is a molecule or ion able to accept a hydrogen ion from an acid. So we always consider bases to be anion. Negative are always bases, while we consider positive as acid. So when they dissociate to water, they produce OH minus, and it always look for a way to join with hydrogen so that it can form water. I asked one of my JAMB students to split water for me. That when you dissociate water, how will you dissociate it? When the person want to split, we call it photolysis of water. When water want to dissociate, it does not dissociate into hydrogen and oxygen, please. It dissociates into hydroxide and hydrogen, please. So let's say that when you are doing your redox reaction, by the time you add your H and OH with equal number, you are going to get water. So if I have 4 OH plus and 4 H plus, I can have 4 H2O, because water is formed by the combination of hydroxide and hydrogen in a chemically way. So because of you see H2O does not mean when you split it, you are going to have H plus O. That is not the correct way of splitting water. So that is water on that. So what else again do you have? Okay, they said an example of base substance can be formed in the bleach, which has a pH of what 12.6 level. So the bleach that you use for your clothes, our hypo example of a bleach, is basic, at the same time has a little bit of what acid. So a base is either an oxide or it can be an hydroxide of a metal. Then these people again, we have the definition that they gave us on base. So let's look at scientists again that comes together before we move to types of this one. So Arrhenius again define a base for us to be what he said increases the Let's look for the proper. Okay. It said a species that produces what? OH minus in an aqueous solution. Arrhenius definition is the one that we use in our SS level. That is Arrhenius definition. So that definition that we all know is from Arrhenius definition on acid and base, and that one is the one we use for our secondary levels. So he said it's a species that produces what? It produces OH hydroxide ions in an aqueous solution. Please, you must always put aqueous solution there, because before they can produce it, they must do what? They must dissociate in water. That's why they try to hammer on that aqueous solution. So that is the definition of Arrhenius equation. So let's see what um yes, Bronsted said base is a proton acceptor. You know that it has said, he said acid is this where I am. He said acid are proton donor. So Bronsted said base are what? They are proton acceptor. That means that the one that will accept that proton that is coming from acid, they will accept it to form a conjugate acid. So they will accept the proton that is coming from the acid, because acid are what? Proton donor, while bases are what? Proton acceptor. So they will accept it. Then what does Lewis say? Lewis said is a substance that can donate an electron pair. You can see that when we look at this guy, the issue of the Al, this issue AlCl3 plus Cl minus, I told you that we always consider our base to be negative. So you can see that is this person now, is this negative chlorine that tried again to give electron, somebody that is negative, still try to give electron to form AlCl4 plus. That's what we are trying to say. So that is what Lewis is trying to explain here, that for the bases they will donate, even they don't have, it is negative that is there, but they will still donate to the acid, while the acid will accept donation from the proton to form Lewis acid and Lewis base. So AlCl4 can act as a Lewis acid, or we can also call it what? Lewis base. Lewis base, sorry. The another one is you can have this equation. When you have ammonia, you can have your ammonia with your BF3. So maybe you have the NH3 plus BF3. So who can tell me who has a vacant shell here? Or we didn't see it. NH3 plus BF3. Between these two, who has a vacant shell here?
NH3.
No, vacant. That does not even have electron at all on it. It is BF3. Now you said NH3, you see what I'm trying to say. Now let me pick nitrogen. What is atomic number of nitrogen? Atomic number of nitrogen.
1.
Is what?
1.
1,
Nitrogen.
1, 1, 1, 1.
It's not one, no. Atomic number of nitrogen. Let's count our, so we will sing it so that we remember hydrogen, helium. Yes, someone is talking.
Is it 7?
It's 7 now. That's atomic number. Atomic number is number of them. Their position number in your periodic table. That's one you always say hydrogen, helium, lithium. That is your atomic number. The number that it falls is atomic number. So it is 7. If you put it in a shell, put it in shell. We are going to have what? Put it in a shell.
That is 2,5.
Exactly. So we are going to have 2,5. So we are using the outer valence electron, which is what? 5. So you will distribute that 5 around nitrogen. So this is what you now do. So we are using nitrogen, that 5, the last number. So if I have my hydrogen here, that means I'm going to have 1, 2, 3, 4, 5. So I want to form ammonia and 3 hydrogen is coming to join with it, 3 hydrogen is coming. So if 3 hydrogen is coming, 1 hydrogen will come here to take this one, another hydrogen will come here to have this one, another hydrogen will come here to have this one. So they will form a bond. A bond will be formed here, will be formed there, will be formed there. But if I look at on this end, there is still what's this thing called? What do we call this thing? This thing, that 2 dots on nitrogen is called what? It's not vacant now. We have 2 electron on it. This is the electron now. So what is it called? What's the name of this electron here? That's the name that we call it. Any electron that does not see someone to form equation with is called what?
Valence.
Sorry, what do you say?
Valence.
No. Have you heard of the word lone pair before?
No.
There's what we call a lone pair. LONE. A lone pair. You know the meaning of pair now. When you're talking about 2 things.
Yes, I do.
There is something we call bonding pair. And there's something we call a lone pair. Bonding pair are the electron that forms a bond. So you see the 2 electrons between this nitrogen and that hydrogen is called a bonding pair because it has bonded, it has formed a reaction. This is a bonding pair, so we can call it BP. But you see these 2 electrons on this my end, looking for someone to pair with, is called a lone pair. So nitrogen is not vacant. It has an electron looking for someone to give. But let's check for bromine. So definitely my NH3 cannot be the what? Cannot be the what are we even trying to say here before we even enter this? Cannot be the acceptor here. That's what I want to say. So it is not an acid, because we said according to Lewis, an acid must have what? Number 1, either it has a vacant, that means there is no electron on it. Either it has a vacant orbital, or it has incomplete shell. So that is an acid according to Lewis, and that kind of a person will now look for somebody to come and give him electron again. So my NH3 here is not an acid because it does not have a vacant electron. It is complete. If you count everything here, it is 8. 1 2 3 1 2 3 4 5 6 7 8. So it still have 2 extra self. So it's not vacant. It's not looking for anybody. It's even ready to give. So now let's check that BF3. Let's check the BF3 and see maybe it's one that is with vacant electron. So the BF3 here, the central atom is always the first person. So bromine is going to be my central atom. So that means my fluorine joined with my bromine. That is the meaning. With my boron. That is not bromine, no. Sorry, it's boron. So my boron here is my center atom. Bromine is Br. Boron is B. So I'm picking this person now as my center atom. So what is the atomic number of boron?
Number 5.
Thank you. Put it in a shell.
2,3.
Awesome. So what number are we going to? What electron will you put around the boron? How many electrons?
The one 3.
Very good. So we're making use of these 3. That's very good. So yeah, let's put it around the boron. So when you have the boron here, you have the 1, you have the 2, and you have the 3. Now my 3 of fluorine is coming. So it means fluorine 2 will bring one electron to join with it. Brings another 1 electron to join with it. Brings another electron to join with it. So if you look at boron, why am I calling it bromine? If you look at boron, is there any vacant shell there?
No.
Are you sure?
There's
The
no
total number
vacant.
of electrons, there is a vacant. Which is there.
Only one of them.
Exactly. This place is vacant. Do you know how I know that it's vacant? For around the center atom, it must always be 8. That is the complete shell. The first shell must always be 2. The second shell must always be 8. So around every element, it must be 8. it must always be 8. So if I look around that boron, if I count all the electrons I have now, fluorine has brought 1. He has 1 already, making 2. Another fluorine comes again to bring 1. Another one also comes again to bring 1. So around the bromine, I have 6 instead of 2, instead of 8. Do you get? If you count it, this is 1 electron, another electron, that is 2, 3, 4, 5, 6, and it must be 8. So it means this bromine will still need 2 more electrons on this place, but it does not have electron again. So that place is vacant. Do you get it?
Yeah.
Or you still want me, please, if you want me to say explain, let me explain again. Who does not get that?
Please come again.
Okay. Where exactly? Where exactly are you getting it confused? So that I know where to come.
I'm getting it wrong from the part where you said that shell is not what's the word? Is not
Okay, that
is
is not
vacant.
complete.
Yes, please explain it. Yes, please.
Okay,
Thank you.
you are welcome. You know that we have shell in chemistry, and we believe that anytime there wants to be a reaction, the reason there is a chemical reaction is because element is trying for a way to be stable. So before an element can be stable, it must be stable. It can be stable in 2 ways. Either it is stable in a form of duplets, which is talking about 2, or it is stable in form of octets, which is 8. So before I can say, oh, this electron is stable, that means the first shell must be 2. 2 electron must be inside that first shell. The second shell too must complete 8. So any element that the second shell is not up to 8, it is not stable. It is not stable. So for every element there must be a stability there. So because of that, that is why we go for reaction that, oh, I want to help this person to be stable, let this person react with this person so that this person can give this person electron, so the 2 of them will not be stable. That is the meaning of chemical reaction, and that is what we are even talking about in chemistry, and that is why we are able to make reaction. So according to the atomic number, I can know which one is stable or which one is not stable. So if I pick bromine as an example, boron as an example, boron is 5. So I'll put it in a shell. I said the first shell will always take 2 to be stable. We always take 2. The second shell will always take 8. And the third shell too will always take 8. So out of the 5, the first shell will come and say, me, I want to take my own 2. The first shell will take 2, comma. Then the second shell will now come. The second shell will ask for 8 because that is the maximum of what electron it can take. But if you look at this, boron is no more with 5, because out of that 5, somebody have collected 2. So boron is left with 3. So because of that, the second shell will say, okay, don't worry, print the 3 like that. So that is 2,3. But does that mean that the second shell is complete? Is it stable?
No, it's not.
Exactly. So boron needs how many electrons to be stable?
Like 5 more.
God bless you. So it needs like 5 more. But this boron still say, oh, they say we should be okay, that I should make use of what I have. So the boron will still say, let me still take my 3 with joy. Let me carry the 3 that I have and look for people that can join with me, so that I'll be 8 and I'll be able to complete. That is the meaning. So this boron will not carry this 3 now. Carry the 3 that he needs. That is what he has. Now we now come and display that 3 for anyone to come and do, or to come and join. So my brother will be here, display the 3, put 1 out of the 3, put another 1 out of the 3, and put 1 out of the 3. So you see, it has tried to wrap himself around his so he's displaying his electron that, see, I have 3 electrons, oh, and normally it should be 8. If it is 8, it's supposed to have what, 4 electrons around it, so that 4 people can come, so that it should be what, 8. But it is 3 that he has. He can't go and steal another electron. So because of that, 3 fluorine is now coming. 3 fluorine say, okay, I want to join. And don't forget that fluorine is what? Fluorine is number 9, right? And that should be 2.7. I'm coming. I will do the fluorine separately. So let us continue. So 3 fluorine means 3 different fluorine will come. The first fluorine will come. That one will drop 1 electron. You know that bromine is having 1 here already. That fluorine will now drop 1, because before a bond can be made, it must be a pair, and a pair means 2. So for a bonding pair, for a reaction, it must be a bonding pair. So it must be 2 electrons. So the bromine cannot join with only 1. Even if you want to join with another element, that element must bring 1. It must be 2 before a bond can be formed. A bond is formed from 2 electrons. So because of that, fluorine will give boron one more electron. Then it will stay here. Another from bromine 2 will come, bring it here, stay in front of this person, making 2. So a bond can be formed. Then another one too will come here, stay in front of fluorine. So you can see 3 fluorine have joined. So making how many electron around boron now? Boron has how many electron now? So instead of 3 now, 3 people have come again to add 1 to the 3 that he has before. So how many electron does he have now?
6.
God bless you. So is it complete yet?
No, it's not.
No.
No. So where do you think the last person will stay?
At the top.
God bless you. But and I told you, before a pair can be formed, how many electrons will form a bonding pair?
2.
God bless you. Out of the 2, boron does not have anything. Does not even have 1. That is why that this place is what? Is vacant. It still needs someone to join, but it is vacant. Do you get it now?
Yes, ma'am.
Uh-huh. And we've done the ammonia. And ammonia has what? That one is keeping. There is 2 useless electron on his head. That one is just useless. Is on his head. And what that called that electron?
Lone electron.
God bless you. A lone pair is on ammonia. So and this one too is carrying for how many? 2 electron. And there is 2 useless electron just laying somewhere lazily there. So because of that, ammonia will now come and give this bromine, will come and join with BF3. So because of there is vacant on this BF3, it makes this BF3 to be what? Acid. Because according to Lewis definition, an acid, its own acid must have a vacant shell. So it is incomplete. Bromo is not complete. It has incomplete shell and it also have a vacant shell. So according to Lewis definition, he said base are what? They are they are electron donor. So NH3 is a base, but it has a lone pair that it can give BF3. So that is why that we have this reaction that NH3 plus BF3 will now give, they will join together. It's going to form a complex. The F3. Don't forget that the NH3 will come and attack itself on the head of what? On the head of BF3. So BF3 dot NH3. So that this will be. So if I want to draw the structure, I'll draw B beside FF under F. Then on top of B, I'll put the NH3 there. So the bond is possible because of the 2 lone pair that is on NH3. So it carry the 2 electrons. Hey, I don't even need it. It's just there. So it carry the 2 electrons and give it to bromine that has a vacant electron, a vacant orbital. Please, are we clear? Do you still want me to go over it again?
Yeah, we are cleared.
It's clear now.
Okay. Okay. So that is the definition of Lewis on base. So are we discussed? Okay, let's move. So after that, we also have the properties of base. we've discussed the. Okay, now let's look at base here. According to the said species with a what? You can see our base, Lewis base must be a species with a lone pair. Another element that has a lone pair is oxygen. Oxygen too has a lone pair, which is water. Water has a lone pair. Let's do the structure too and see the lone pair I'm talking about. I told you a lone pair is what? It's just two electrons, two paired electrons that are just useless, waiting for bonding. There are two, and nobody, they are not ready to bond with them. They are just there looking. So let's look at oxygen. Since oxygen is what? 6, and that will give us that will give us 2,4, right? So if I pick my oxygen, I can do it as 1, 2, 3, 4. So it's going to bond with, sorry, is oxygen 6 or 8?
Oxygen is 8.
Oxygen is 8. So it's going to be 2,6. I know that oxygen is group 6, not group 4. So 2,6. Oh, it is 8. That is 2,6. So I'm going to have oxygen. I will have 1. And I hope you know how you distribute your what's it called? Your electron. You first do it singly before you start pairing. So I'm going to have 1, 2, 3, 4, 5. Let me put it this way. This is what I'm trying to do. Okay, 8, 2,6. So I have my oxygen here. So I want to now, we are making use of what? Of 6. Spread the 6 around it. I will first, it must always be in 4 places because the total should be 8. This my oxygen 2 is not complete. The second share here is not stable because it's supposed to be 8, but it is 6. So I will now distribute it around it. I will have 1, I will have 2, 3, 4. I still have 2 more. So I can put 5 and I can put 6 here. Let me put it at that side. Okay, 5, and let me put the 6 here. So to form water, don't forget that 2 of what? 2 of hydrogen joined with what? Oxygen. So 1 hydrogen will come, bring his own electron. Hydrogen will bring his own electron, stay here to form a bonding. Another hydrogen too will bring 1 electron here and stay here to form a bond. So how many lone pair of electron do we have for oxygen now? I'm supposed to have that. Okay, is there lone pair?
Yes, ma'am.
We all know the meaning of lone pair now. So how many lone pair do we have?
2.
2. Very good. How many bonding pair?
2.
2. We are scholars now. So that you can see, even this, that means even water too can act as what? Water can act as Lewis base, and water can also act as Lewis acid. Because of that, water is known to be what? As amphoteric. Amphoteric substance are substance that can act as base and they can also act as acid. So example is what? Is oxygen, because the reason it is acid and oxygen, like acid and base, let me explain. When you try to dissociate your water, I said it's going to give us what? OH minus and H plus. So as long that my water can produce hydroxide ion, I said hydrogen ion, sorry, it can produce hydrogen ion as only positive ion. It means it can act as what? As an acid. Because my water is also having a lone pair, and according to Lewis definition, he said our base is going to have a lone pair. So because my water is also having a lone pair, I can also consider it to be what? To be a base. So because of that, my water can act as an acid and can also act as a base. That is why water is also one of the that is one of the characteristics of water to be universal solvent, because it can dissolve at least 90% of different substances. So it can act as base, and it can also act as what? As solvent, as base or as an acid. So because of that, water is amphoteric. That means it can act as base and can also act as an acid. Any question, please? Me, I have question o after the class, so please ask your question now. Is our time up? We are almost done. Let us finish
Yes,
the so any question? I'll round up so now, so that we know that we are
no, ma'am.
starting from no question, right?
At all.
Okay, thank you. So we've discussed this, so the same way that we have strong base and strong acid and strong acid and weak acid, we also have strong base and what? And weak bases. So your strong base will combine essentially completely with H, while your weak base can just be considerably what? Less reactive. Less reactive. Dem say strong bases are the soluble hydroxides. Any base that can dissolve in water, not all bases can dissolve in water, please. Not all bases can dissolve in water, but any of our bases that can dissolve in water, it is called alkaline. That is where the word alkaline is coming from. So your alkalines are soluble bases. That means there are bases that can dissolve in water, while we have some bases that cannot dissolve in water. So any base that cannot dissolve in water is still called base, but any base that can dissolve in water is called alkaline. So that is different, please. So our strong bases are the soluble hydroxides, which are the alkaline metal, and heavier alkaline earth metal, which is hydroxides. I hope you know the meaning of alkaline metal. This one is bringing us to a periodic table, our group 1 elements that are called alkaline metal. And why are they called alkaline metal? Because they can react with water to produce base. That's why they call them alkaline metals. And I told you that alkaline metals are soluble bases. That means bases that are soluble in water, while your alkaline earth metal are the group 2 elements. Then again, these substances dissociate completely in what? Aqueous solution. So we've discussed this man's definition. So here, what are the types of our? We have strong base. Our strong base is what? KOH is very strong. KOH. Which one again? NaOH. They are strong as strong base. LiOH strong base. But you cannot have your fraction and cesium to react because they are very reactive. They explode when you react with water. So what are the physical properties of our base? It tastes bitter, feels simply like what? Like soapy. Also conduct electricity. Your base, some of your bases can conduct electricity because they can ionize water to produce ions for us, to produce cations and what? Anions. Because if I try to dissolve NaOH, I'm going to have NH plus OH minus. Because of I'm having a complete ions, so it can also conduct electricity. It's rarely found in colored solutions. Most do not have a smell except ammonia. So can I tell what is the smell of ammonia? We did salt analysis now. What is the smell of ammonia? It has a smell except ammonia. So others bases does not have a smell. What is the smell of ammonia? You don't know it?
Smell.
The smell of ammonia.
I don't know. No idea.
Do you like
Okay.
fingers?
It's not having gas. So that one gas is nitrogen oxide. Ammonia is NH3. It has a choky smell or a urine smell. It has a urine smell. This conk urine, people, someone that has maybe conk fever, that smell, that is smell of your ammonia. Even if they open it, you think they open urine. So it has a urine smell. So we call it a choky smell. And if you perceive it directly, it can give you irritative throat. You start coughing. The next one is it turn litmus indicator blue. Your litmus paper, it turn is blue. Then if it is enough phenolphthalein, it turn it indicator to what? To pink. This indicator you are trying to talk here, we are talking about when using your titration, when you are trying to titrate your acid against your base. So if it is base against acid, it's going to turn it blue. But if you use litmus indicator, that is your litmus paper, if you use your litmus paper as indicator to get, it's going to give you blue. And if you use your phenolphthalein as your indicator, maybe you use you put your phenolphthalein inside your base before you start shaking it, the end product is going to give you pink as your end product. So that is the meaning. Then we also have the chemical properties of bases, and this one talks about it reacts with fats to form soap and glycerol. So this process is called saponification. So your base can react with your soap and can react with glycerol to give us to form soap. Sorry, it can react with fats to form soap and glycerol, and the process is called what? Saponification. Then your base has a what? Have a pH that is more than 7, and I told you that any pH that give us 7 on the dot is a neutral substance. Then it dilute solutions of bases taste bitter. Some dilute taste bitter. Don't go and do any taste test in the lab, please. We don't taste in the lab, please, I beg you, don't taste in the lab. And most important, when you are going to lab, when you are in that institution, go, even they will tell you to go with nose masks, because there are some toxic substances that you will perceive for like 1 week, you not get yourself. Don't go and do any test smell. Oh, if anybody has to go and smell something, tell the person to smell it back. And when somebody is shaking chemical, please move away from the person. You don't have chemical splash, please. All these chemicals are very dangerous and corrosive. Then bases turn phenolphthalein pink, litmus blue, and bromitimol blue. Then bases neutralize acids to form what? Salt and water. The bases are also formed when alkaline metals or alkaline earth metals react with water. The words alkaline and alkaline mean basic as opposed to acidic. So we discussed that and that. So the last part is the basicity of an acid. That is the last part of this class, and we call it a beautiful day. So for the basis of an acid, we said is the number of hydrogen ions produced when 1 mole of an acid ionizes or dissociates in water. Now when you dissociate your acid in water, the number of hydrogen that is going to produce is what we call the basicity of an acid. So if I dissociate my HCl, I'm going to have H plus and Cl. So how many hydrogen is being dissociated? 1. So it means the what? Is a monobasic. HCl, if I dissociate it, I'm going to have H plus Cl minus. How many hydrogen is there? Just 1 hydrogen. So because it dissociates just 1 hydrogen, the basicity is what? Basic. So it is what? 1. If I look at the second one, H2SO4, your H2SO4, if I dissociate it, is going to give me H plus SO4, 2 minus. Then to balance the equation, I'll put 2 in front of this hydrogen. So how many hydrogen is being dissociated? 2 hydrogen is being dissociated from H2SO4. That one makes it to be what? Dibasics. That means they ask you that what is the basis of H2SO4? The answer is 2. Trying to ask you that how many, the meaning of that English. Let me come again. When the question says what is the basicity of H2SO4, in your option you see 1, 2, 3, 4. The answer is 2. The English means how many hydrogen will I get if I dissociate H2SO4? That is the English of what they are asking you. Then now put it that what is the basicity of H2SO4? The English is how many hydrogen will I get if I dissociate H2SO4? So moving on, we have the HNO3. The HNO3 too, if you dissociate it, the basicity is going to give you what? 1. That is monobasic. So I'm going to have H plus NO3 minus. If I dissociate my H3PO4, I'm going to have H plus PO4 3 minus. Then to balance the equation, I'm going to have 3H plus. Let me write it. This is what I'm saying. H3PO4. So if you dissociate it, you are going to have H plus PO4 3 minus. But to balance the equation, I'm going to have 3 hydrogen here. So because of 3 hydrogen, it is called tribasic. So the basicity of H3PO4, it is 3. The answer is 3. That means how many hydrogen will you get from H3PO4 when you dissociate it? The answer is 3. Then the next one that is very common, and even if they want to ask, this is what they ask in JAMB question. They ask the ethanoic, which is CH3COOH. People always make mistake. They'll go and pick 3. The answer is 1. Now your ethanoic acid in your organic compound, it is only one organic compound that is acidic, and this compound are called carboxylic acid. You know that we have your alkane, you have your alkene, you have your alkanides, your alkynes, you have your ketone alkanoids, you have your alkanol, you have your arachidonic. So your arachidonic acid, also known as what? Carboxylic acid. They are the only acidic organic compounds we have.
Don't
Yes.
worry. No, don't worry. It's one time. I'll go.
Do you want to ask questions?
I'll go to wait.
Yeah, ma.
Okay.
Yes, I was, I'm kind of having
I'll start at that
issues. I
moment.
was having issues with the
Oh,
dissociation of the
oh,
acid,
yeah, we're good. Hold
Okay.
on.
Don't have
like
to
how it
dissociate it.
works, how to do it. It's a little bit
Yeah,
confusing
I drop it
how to
now. You
dissociate
have to
acid
start
and the rest.
again.
Mute
I said
yourself.
you have to.
Mute yourself, please.
Yeah,
Thank you.
yes. But I want to sleep now.
Please know that we have to. How many elements is coming together to give you a period?
Ma, please, can you mute this person? I'm not hearing you.
Everything in the room. Yeah. I'm not in the room.
Yes,
Roof,
guys.
you don't say roof. You say roof. I'm not touching roof.
What's her name? Okay, it's even Ibrahim. Ibrahim, mute yourself. Ibrahim, mute yourself. I can't mute you. I'm trying to mute you. Thank you. Okay. Now, if you look at your ACL, how many elements is coming together? Two different elements, hydrogen and chlorine. So, hydrogen and chlorine is combining together to give you ACL. Dissociation means scatter them to their normal element. So if I scatter it, that means hydrogen will stand alone, chlorine will stand alone. That is the meaning of dissociation. So hydrogen will stand alone, but it's going to form an ion, and hydrogen is always plus. All of them will carry their charge for head, then plus Cl minus. So I've scattered it. That is the meaning. Then I'll balance the equation. For my reactant, I have one hydrogen. My product, one hydrogen. My reactant, one chlorine. My product, one chlorine. This is how to dissociate it. So let's pick another one. H2SO4. H2SO4. SO4 is a radical that can stand alone too. So I want to take hydrogen away from them so that it will stand alone. That is not dissociation. So look for a way to take hydrogen away from them to stand alone. So if I take hydrogen away from these people, I'm going to have H plus. Hydrogen is always H plus. Then plus, if I take hydrogen away from H2SO4, I'm going to have what? SO4 left. So plus SO4. That is how to do it. 2 minus, because the charge for SO4 is always 2 minus. So I want to now balance it. In the reaction, in the reactant, I have 2 hydrogen. So in the product too, I must have 2 hydrogen. That is the meaning.
Okay, ma. Noted. Thank you, ma.
You are welcome. So can you dissociate H2CO3 for me? H2CO3. H2CO3. I told you what you are looking for is a way to take away hydrogen from them. So when you take away hydrogen from them, you are left with what? CO3. And CO3 always have a charge of 2 minus. Can you try?
Yes, I got something on my paper here.
Oh
Um,
yeah. Wow. Don't worry, say it.
2H
2H.
plus
Very
2O3.
good. Plus CO3. You are right
Yes.
now. Yes. Why are you not afraid? You are right. So that is how to dissociate it.
All right.
So you are
Thank you very much, ma.
you are welcome. You are welcome. So let me explain this carboxylic so that you know why it is monobasic. The hydrogen that is going to dissociate will only come from the COOH. So no matter what you have here. So because some people are seeing CH3 here, COH, so they would think this the hydrogen from here is one that will dissociate. No, the hydrogen that would move away from these people is coming from the COOH. So if I want to dissociate CH3COO, this is what I'm going to have. I'm coming. So if I CH3 COOH, so if I dissociate it, I'm going to have CH3 COO minus, then plus H plus. So how many hydrogen is here?
So
Ew. How many hydrogen is dissociated from that thing? How many hydrogen is standing alone?
One.
One now. Are you not
Yes,
seeing
ma'am.
it? Let me do it again. It's one now. I told you that the hydrogen comes from OH. So this hydrogen here will move away. So if hydrogen moves away, it's going to stand alone here. Ew. Sorry. So it's going to stand alone here to have H plus here. Do you get? Then plus, now this hydrogen is no more there. So I'm going to have the CH3 COO minus. So how many hydrogen is being dissociated from here?
One hydrogen.
That is why your earth dialogue is what? Monobasic. And this is what they always ask you. They use this thing a lot. But you know that people always make that mistake. So the hydrogen that will dissociate is coming from the acid, which is the COOH. That's where the hydrogen that will dissociate will come from. So CH3COH, the basicity is what? Monobasic, it is 1. Then your H2CO3 is dibasic, which is what? 1. So that is the, I think that, yes, that should be the last slide for this. So
Yes,
any
ma'am.
questions
It's
so
the
far?
last slide. No, ma'am. There's no question.
You are tired.
Thank you so much, ma'am.
I
Yes, ma'am.
appreciate. I really appreciate. Thank you for coming late. Thank you that I said thank.
I'm listening.
Sorry, I came late. Actually, that's what I have to say. I'm
okay,
sorry that I
ma.
came late. Okay, thank you so
Thank you,
much.
ma'am.
All
Thank
right, ma.
you.
Good night, ma.
Good night, oh. Make
Have a
sure you
good
read
one.
out. Okay, take
All
care.
right.
We move to the next class.